Hello. I'm going to demonstrate a very exciting new technology, the SANSlide Data Transport Accelerator. What we're looking at here is actually the management console of the SANSlide device. Very simple. And we're going to go into the demonstration portion of the system here and talk about what we're going to demonstrate and how. In effect, what we have here is a SCSI data source transferring across to data sync. It really doesn't matter whether it's SCSI, iSCSI, fiber channel, it makes no difference to us. But we have the two SANSlides, and initially when we start out, they're really not doing anything. In the middle here where it says delay, we have Wemulator, which is an open source wide area network emulation program that lets us simulate the kind of conditions that we see in wide area network environments around the world. We're going to begin a 16 gigabyte data transfer, and we're going to go back over here and look at the transfer statistics so we can kind of look under the covers at what's happening as the data is transferred across this environment. So we start out, we have no delay, so zero latency, and the artificial intelligence represents the SANSlide technology. Essentially wire speed, 99 megabytes per second. We're transferring data across the desk. Plain old Ethernet, simple enough. But as any network engineer will tell you, when you apply latency, which is what occurs when you insert a wide area network connection in here, that's delay, and that delay dramatically impacts the throughput of data across that link. So we've introduced 30 milliseconds of latency, which is a little less than you're going to see in kind of halfway across the United States, according to sort of the standard model. And that's with an optimized WAN environment that does not have any other issues or problems. And we see this dropping to about 3 megabytes per second of throughput. And by the way, on the left here, this axis is dynamic. You will see that it will change over time as we go through the demo. It's very important to pay attention to what this top number is, because that represents what's really happening in this window of time that we see scrolling across the screen. Now, the next thing I want to do is turn the artificial intelligence on. So we basically inserted the SANSlides into the environment. What we're going to see them doing is beginning to communicate with each other and creating those virtual autonomous virtualized connections so that we can now optimize data throughput and overcome the latency problem. And as the SANSlides communicate, again, watch this left axis, you'll see the data throughput will continue to increase as they create those virtual autonomous connections within the virtualized TCP/IP tunnel. And once they've fully optimized the link, you will actually see that the transmit rate or throughput exceeds wire speed. It's actually faster across halfway across the country than it is across the desk. We'll actually top out here around 117, 118 megabytes per second, and you'll kind of see this begin to flatten once the link is fully optimized. But of course, again, as any network engineer will tell you, or telecommunications engineer, wide area networks are not static, they're dynamic, so latency changes over time. So we're going to apply 60 milliseconds of latency here, simulating either a decrease in network throughput on the wide area network, or perhaps a longer distance going closer to all the way across the United States. So what happens basically is the two SANSlides, they see that change. The artificial intelligence, which is of course self-configuring and self-managing, adapts to that change, and very quickly we see the throughput right back up where it was before that change in the network conditions. And this happens all the time. So because the artificial intelligence is constantly looking at network conditions and adapting to them, we can maintain this high level of throughput throughout the data transfer process. So again, for disaster recovery, backup, data replication, whatever the need may be, it really overcomes the latency problem as well as packet loss that happens in wide area networks. Now, to sort of finish out our demo, I'm going to reduce the, actually I'm not going to do that. I'm going to turn the artificial intelligence off, and we'll see the effect of the SANSlides being taken out of the picture. Again, still our 60 milliseconds of latency or delay here. Of course, we rapidly see the throughput dropping to this, let's see what we have here, less than 2 megabytes per second level, which is again what we would expect with that much latency, again, transferring almost all the way across the United States. And then finally, we'll take the delay out. So we're now going back to wire speed, back to the across the desk sort of environment where we began. And one of the interesting things here is you'll notice this will very quickly climb back up to that 99 to 100 megabytes throughput per second of throughput that we saw. So you're actually seeing this here is the difference between wire speed and SANSlide speed. So literally transferring data faster across the country than we do across the desk.